Hey guys, happy Monday. Hope everybody enjoyed their weekend, was able to get outside a little bit and try to enjoy themselves. We're on our day three of notes here with trig identities and trying to verify them. We want to make that left side somehow equal the right side. We're going to continue to refer to the left-hand side of the screen, the identity sheet that you were given. But today's focus is only two problems, and it's one method. It's find the common denominator. Okay. So this is a method where you can kind of treat it just like you would with algebra concepts when you would add or subtract, rational expressions. So it's a little lengthy. It's going to be a little tough for me to draw using the mouse here. So just bear with me. But that's again the focus. Find the common denominator. Okay. So if you take a look, see what we're given here. The first thing we would say is, all right, well, the two denominators, 1 minus sine x, 1 plus sine x. I guess what we called our least common denominator would be the first thing that we would form. So I'm going to write that here. I'm going to write 1 minus sine x and 1 plus sine x. Again, hopefully as you are watching these videos, you are taking notes. No need to submit those notes to me. I can just monitor if you're watching the videos in its entirety. All right, I'm giving you credit for doing so. All right. So there's our least common denominator. Now, as we form that, now it would be, well, okay, well, what's the difference between this denominator and what we just formed? Because we would have to then go and multiply the numerator by that missing piece, right? So I'm going to multiply this 2 by 1 plus sine x. So some people call this like cross multiply. It's really not. This is just adding and subtracting fractions, right? So 1 plus sine x. We're then going to have to multiply this 2 as well, or this fraction, by the denominator that's missing, which would be 1 minus sine x. All right. The next step, we're just going to go and distribute those 2's. So let me scroll down here, give myself a little more room. And now I'm going to distribute this 2 in. So it would be 2 plus 2 sine x and over here it would be 2 minus 2 sine x. So again, just distributing. And now we'll simplify like terms up in the numerator. I'm going to try to save myself and you guys right now some time by not rewriting this denominator. But this denominator has not gone anywhere. It would just come down here. Okay, so I just distributed it to the numerator about the group-like terms here. As we can see, we can cancel out or simplify. These terms would subtract 2 and 2. We would now have 4. All right. Now, what I am going to do in this next step is, because I know we have to somehow get secant. All right. Secant, I know, is the reciprocal of cosine, so it'd be great if I can get cosine somewhere in this problem. And I'm looking at the denominator here, and I'm saying, all right, well, if I just write that down, we're not really getting anywhere. But maybe if I distribute, if I multiply these, let's see where it gets. And like I said, like I've said in each one of the videos, you can't be afraid to do a little trial and error. So if I FOIL and I multiply 1 minus sine x times 1 plus sine x, the result of that, it's kind of like the difference of squares there, would be 1 minus sine squared x. All right. And as we focused on the other day, this Pythagorean identity, we've seen this a few times now. We know that this right here equals cosine squared x. All right. So by us multiplying our denominator, FOILing it out, getting 1 minus sine squared x, we then use the Pythagorean identity to now somehow get cosine into our problem. We're still not done. We need to now make cosine secant somehow. So the next step would be to use what we call our reciprocal identities, right? We know that cosine is 1 over secant, right? So another way I could write this right here would be if I were to just write 4 divided by 1 divided by secant squared x, right? Secant 1 over secant squared x is the reciprocal of cosine. And rather than divide by this fraction, we could just simply multiply by its reciprocal, and that's how we would come away with 4 secant squared x. All right. So the first thing would be to add the fractions. We got to somehow come up with that least common denominator. We're going to have to change or alter our numerators, distribute or multiply, combine like terms, and then work with that denominator so that we could get to where we needed to. Okay. And that's what led us to cosine squared x, which we eventually then transferred that to secant and got what we needed to verify it to be. All right. The next example looks very similar, but if you notice here, what changes? Well, the denominators, instead of sine squared or instead of sine x in the denominator, it's now cosine. It's going to be the same process that I take here in this next problem. So maybe I'll try to shorten it up a little bit, try to make it a little less writing, and you guys can always do the same. So first off, my denominator would be 1 minus cosine x and 1 plus cosine x. The next step would be for us to multiply our numerators by that missing piece of the denominator, if you will. All right. So we know that we would have to multiply this by this denominator here. So 1 plus cosine x. All right, this numerator would get multiplied by this denominator. That's where some students will use the terms cross multiply. If that's how you want to think about it, that's fine. All right, and then 1 minus cosine x. So just writing it a little differently, but doing the same thing as we did in the last problem, basically. So now go ahead and distribute, and that would give us 3 plus 3 cosine of x and over here we would get 3 minus 3 cosine x. So the same thing as we saw in the last problem is happening here. As we distribute and as we're about to group like terms, we're noticing that 2 of the terms here are going to cancel. 3 and 3 would give us 6. And now we say, okay, well, how do we get cosecant, right? We would need sine somehow in the problem. We can begin to see that this right here, the difference is 2 squares here. If I FOIL this out, I might be able to use that Pythagorean identity. And if we FOIL this, it would be 1 minus cosine squared x. All right. And by now we should have seen this enough where we really have an understanding of this Pythagorean identity. All right, this identity right here, because this, you know what, move this over a little bit, give myself some more room. This would be 6 over sine squared x, right? Where did I get the sine? Well, again, using the Pythagorean identity, this right here is equal to sine squared x. Okay, we still don't have cosecant, but again, very similar. We just use the reciprocal identity. So this equals 6 over 1 over cosecant All right. And rather than divide by this fraction, I can bring it up, multiply by its reciprocal. And that's where we get our answer and how we would verify it to be 6 cosecant squared x. All right. Scroll back up here. All right. That's what we had to get in the beginning, we were told to. And that's what we ended up with, okay? So guys, hoping these videos are good. You're benefiting from them, being able to stop and go back or pause as you take the notes and continually refer to them. So I'll post this in Classroom today. Later on today, you're going to see another worksheet posted, and we'll kind of just continue to work through different examples. But guys, don't hesitate to ask any questions. If it's probably best just to shoot me an email. I don't always see the questions or the comments that are inside Classroom. I don't always see them right away. So maybe the best thing would be to just shoot me an email if you have any concerns. All right. Again, guys, stay healthy. All right. Thanks for doing all the work. Appreciate it. All right. Talk to you soon.